Okay, so drugs, including drugs of abuse, affect cells, right, affect neurons, affect transmission in many of these systems that we've been describing, like the limbic system, right, like cortical networks that are associated with cognitive functions like memory, right, etc. And they do so by interacting with receptors, right? That's one of the primary modes of drug action, right? Are drug interaction with receptors. So I want to examine, at least two ways that drugs can influence, neurotransmission at a synapse by acting at receptors. So this is our postsynaptic neuron, right? Here's our postsynaptic membrane right here with the receptors, arrayed out here. And let's say we've introduced two different drugs, okay? And these drugs are going to influence these receptors, okay? Now, this drug here, this kind of, this drug right over here that's going to interact with these two different kinds of receptors, our ionotropic, right, receptor, and our, metabotropic receptor. When this particular chemical comes in and interacts with these receptors, it binds to it, and it causes a change in shape, but the change in shape prevents the normal functioning of this receptor. So for an ionotropic receptor, if you had your typical neurotransmitter released, presynaptically, it would come over here, it would bind to this, ionotropic receptor, you'd get a change in shape, and you'd open a hole, and ions would go through. This drug has bound to this same receptor, though, and it's preventing the neurotransmitter from binding, and it's preventing the thing from opening. It's not going to open. So, and the same is true over here. If you look at a metabotropic receptor, we have, a typical neurotransmitter would come over, and it would bind to the metabotropic receptor, right? It would cause it to change its shape and release a G protein, right? But in this case, this drug has bound to this, and it's caused a change in shape, but it's prevented the release of the G protein, okay? So this drug that blocks the normal, typical action of these postsynaptic receptors and prevents the neurotransmitter from binding, and normally activating these receptors is called an antagonist drug. This is a drug that is an antagonist at these receptors. In contrast, over here we have a drug that is going to, find its way, cross the blood-brain barrier, make it into the central nervous system, let's say, and interact with our ionotropic receptors and our G protein coupled receptors. But as opposed to the actions by antagonists, agonist drugs will actually bind to these receptors and activate them. They will pretty much sort of replace the normal action of the neurotransmitter that would be released here. So we see here an agonist drug binding to an ionotropic receptor. There's a change in shape, and it opens the receptor. It opens the channel to allow ions to pass through, as if this were the neurotransmitter. It's an agonist drug. The same is true over here with G protein coupled or metabotropic receptors. This agonist will bind on here, and it'll provoke a change in shape that will release the G protein. So agonists are drugs that bind and activate receptors, sort of like neurotransmitters. And antagonist drugs are drugs that bind to neurotransmitter sites, but they block those receptors.